Let's start this session. Please take your seat. We'll start shortly. So welcome to the European Data Landscape session. Thank you very much to the attendees for choosing this parallel session. And also to the presenters. We will have today 2 remote presentations and 1 presentation in person. But the topic, as you know, is very relevant. So it's important to remind that, building the EOSC is something that relates a lot the whole community, efforts from many different initiatives, research communities, infrastructure, interdisciplinary actions, and data spaces and other destinations of Horizon Europe's plan are key contributors to this that should be really considered. So in this session, we are going to cover 3 presentations. One will be covering the destination Earth and the digital twins. Second, will be focused on this famous European Digital Infrastructure Consortium, the EDIC, this new instrument that is being prepared for facilitating the sustainability of this kind of infrastructures that come from especially data spaces, and 1 flagship project in the health data spaces domain on cancer imaging. So our first speaker is Niels Veddi. So Niels, please, when you want, you can start sharing your presentation, your screen. So Niels has developed a very long 28-year career at the European Centre of Medium-Range Weather Forecast, SCMWF, on a diverse range of work from technical and scientific, and he is currently the digital technology lead for Destination Earth at this institution. So his presentation, Destination Earth, implementing digital twins of the Earth system, will be given right now. So Niels, you have 15 minutes. Thank you very much for that. We don't hear you, Niels. Check if you are mute. We can see this. Now we can hear you.
I lost the controls.
You have to, yeah. Now we can see and hopefully hear.
Okay, you can hear me, yes? Good. Yes, thank you very much for this invitation to give an overview of the current status of the implementation of Destination Earth and the wider landscape, of course, in the context of the data that will be available to researchers and also policymakers ultimately in this important task of both warning for extremes and climate adaptation. So without further ado, let me just give the background of the landscape that we are looking at. I like to start with the Microsoft Flight Simulator. Was perhaps the first way they presented substantial, realism by invoking quite realistic-looking clouds and real weather into their flight simulator. But I think we have gotten quite much further from games, even if we actually start to use also technology from the gaming industry, be it GPUs or be it also the visualization engines. It has emerged into a wider perspective of whether you can combine the power of machine learning, the power of supercomputing, the power of physical modeling knowledge in a better provision of seeing our future. Now, NVIDIA, in this example here, is trying this also as a private enterprise, together, of course, also with the scientific community, and also like making essentially their tools here available. But in Destination Earth, we try to go basically beyond this as well. So there are other elements that I mentioned. Machine learning is starting to outperform even the world's best medium-range weather forecasting system in some aspects. The system so far was ECMWF's system. And we start to see also a different way of communicating this information. Like you think ChatGPT, think how this information can be combined, and how say we can ease the process of accessing this information. Of course, there will be errors in the provision of this information, and maybe you only get 80% of the information. But for somebody who has got nothing, this is quite a good start to kind of start to build your opinion and start to build, without necessarily trusting everything right now, as trust, of course, and knowing what is going into some of these machine learning algorithms is an important aspect that is sometimes difficult to verify, of course, when it's created without allowing you to look behind the scenes. So this is where Destination Earth is trying to sort of come in as well. Using these technologies, of course, in a way for the wider European landscape, for the wider European user community. Here's an example of where we are today in terms of comparing, if you like, the power of the simulations that we can do on the right-hand side at 2.8 kilometer resolution with the latest in European satellite technology from MTGI. And we started to see really incredible details and an incredible match, actually, in the observed radiances from the satellite information and the simulated radiances derived from the simulation data. So this is obviously one pathway, but it's just only the global pathway. And it's therefore combining the expertise of the different institutions, ECMWF, ESA, and EUMETSAT, three European institutions, together with the European Commission, DG Connect, and of course, through these and through contracts involving hundreds of European research and computational scientists from industry, academia, and national institutions, contributing to this vision of creating a new information system with novel access patterns to this information. So this incorporates on-demand data streaming. It incorporates the continuous production of data information. There's, of course, this fusion of observations and simulation, and it should allow also what-if scenarios. So a kind of an understanding of, if you don't have enough information, it should allow you to kind of create this information in a way on demand in order to better sample the uncertainty around what if something happens. And I will perhaps give some examples on that later. And the other big aspect is, of course, that we want to transition between the global scale and the local scale with the corresponding advantages and in the quality and also targeting scales where, for example, climate change is observed, which is typically at the local scale. And of course, all of this needs computing, supercomputing resources, substantial supercomputing resources, and therefore the connection and connectivity and interoperability with your HPC systems is a crucial element of this undertaking. So innovation happens both, of course, on the Earth system modeling side and these digital twins itself, but it also happens in the interaction with the users in terms of understanding what they require, but also in terms of making the information flow more easily than perhaps is accessible today. Also in the context of the European vision of different data spaces, the connectivity between these different data spaces where climate and weather information, extreme weather information is a component that you might want to use in fuse with other disciplines. And the accessibility and interactivity of producing this information or producing target information that you require without necessarily having the deep knowledge of Earth system modeling, complex Earth system modeling, is one of the visions of this undertaking. I'll skip one too quickly. So here are some examples of use cases that we are contracting within this undertaking to give you an idea who we sort of interact with our information that we're providing from the digital twins. So there's renewable energy planning, resource adequacy, grid planning and validation from energy systems. We're interacting with air quality models and here like air pollution at local scales. We're looking at compound flood risk. In this context with a partner, we're looking at urban heating and coupled urban climate modeling. And we're looking at wind damage predictions here in this context. So say damage to harvesting conditions, and even if and then what actually the forestry conditions, for example, in order to be able to even enter the forest given certain weather conditions. So these are just examples. All of this is in the mix of the EUMETSAT provided Destination Earth data lake, which combines, of course, foremost the additional information of the digital twins, which are very high resolution, very large, big data sets. And so the managing of these big data sets, the processing at the edge, the processing at near the data is a sort of key component of this, where ECMWF is also closely involved as the producer of this data. And the vision of bringing the users closer to this data in a distributed cloud computing environment. And then, of course, as I mentioned already before, the wider context of other data spaces and easing the access to different sources of information. So we are responsible, as I said, for the implementation of the digital twins. We're partnering here with the French Meteorological Service, Meteo France, and 22 European countries, partners from these countries, to implement this configurable capability for this interactive European monitoring and prediction framework. This is implemented on the two computers, Leonardo and Lumi, right now. And here's just one example where the continuous global component at 1 to 4 kilometers feeds the information on an on-demand regional component that can be selected and targeted and moved in terms of its target region as, say, for example, a storm moves or as incidents basically happen in a particular region. Here was one example, which is a nice kind of case that we are looking at, where in Germany, the electricity grid almost collapsed on the 12th of June 2019. There were newspaper articles about this, I think also in the Spiegel, which was an interesting case because the storm was actually badly forecasted here. And what happened was that most of the providers of the renewable energy decided to rely on a bailout mechanism because it was cheaper for them to rely on the bailout mechanism, at the time at least, than to go onto the open market and supply energy that they hadn't planned for. And the bailout mechanism, unfortunately, was then completely overloaded and was struggling itself. And to the extent that Germany got very close at that time to a complete breakdown of the electricity grid. And so in the context of relying more and more on renewable energies, actually across country boundaries, it is, I think a nice illustration example where digital twin information can support planning for these kind of, for these things not to happen, actually. Of course, regulatory frameworks also have to change in this condition. They did to make sure that it's not actually cheaper to rely on the bailout, but for everyone to kind of have more responsibility in contributing to the stability of the energy network. But that's aside. So the other role, as I said, is climate change adaptation for the digital twins and adaptation policies and mitigation scenarios. Here we contract the Finnish CSC Computing Center with, again, many partners from the European community to establish these first climate digital twins on Lumi and then later on Mare Nostrum 5. Here are just examples from global information with local granularity and comparing this, say, with what we currently derive from IPCC AR6 information at 100 kilometer resolution, just to give you an idea how much more, say, local we can provide information over the next 30 years into the future with here our prototype digital twin. As I mentioned, we're exploiting the world's leading European HPC platforms in this undertaking and are working on mechanisms and improving the accessibility to these machines in partnership with the JU to make the best use of these machines for problems that are really relevant to society. One of the vehicles of doing this is what we call the digital twin engine. So it's software development, software environments that ensure that we can run these complex simulations in the EuroHPC. It ensures the managing of the big data. We're looking also, of course, at standards of data, fair principles, and looking at the overall ability to share information as widely as possible. Of course, we're linking to machine learning algorithms and look at the efficiency of bringing this data together with machine learning algorithms and also in the context of estimating uncertainty, because we would like to provide bounds, of course, on the information that we provide. And finally, the aspect that also is covered by digital twin engine technology is tailoring information to users' needs, and this aspect of interactivity that allows people to even involve or be involved, basically users being involved in the configuration of the twins that are running both on demand and the continuous sort of production. And there are various pathways to allow this interactivity that we're developing in Destination Earth, both on the data and also the simulation side. So this is just an overview slide on this interactivity, that it can take different pathways. As you see, like this red grid has different options, different ways of being notified by availability of data, different pathways of how you might tailor the production pipelines, how you can interfere with programmable pipelines that attach, if you like, to the running digital twins, and therefore provide much more tailored information to the requesting users. And here's just one example where, I mean, we're not the only one. Of course, there are many other digital twins sort of currently being developed and that want to ultimately maybe plug into this environment. And so here DTGeo is just one of those examples where, and together with this eFlows for HPC project, they color-coded in a way different parts of the workflow environments, different parts of the distributed execution, and different elements like registry and so on that are relevant in this context. And on the right-hand side, we try to just map this basically with the offerings that we are currently using in the digital twins in Destination Earth. But the main message here is that we are mapping really to similar concepts, but maybe the tool choices differ, and maybe for good reason, in fact. And so, like, there's not like a, you have to use this and that, but basically you have to, if you like, agree on a similar sort of conceptual design in order to participate basically in the Destination Earth framework. So in summary, novel investment in infrastructure and technology, and we would like to embed this Earth system information, in this case, into the wider digital environment to enable the creation of new information driven by what the users really require for their particular task. And that's all for me.
Thank you very much, Niels, for the presentation. So we have time for a couple of questions in the audience. Is there any question? I mean, to warm up, maybe I can make one. I would like to, if you can explain it a bit, because you deal with a vast amount of data. How do you make this data available to the researcher? I believe that there will be services, there will be environment in which the user can select parts of the data, environments to process. How do you deal with this problem?
Yeah, of course, the transition of the data from the production side, the Euro HPC machines, is vital. So our, if you like, data planners that we have actually installed a data bridge now at LUMI, which is a physical hardware infrastructure that stores the information that is produced and streamed, if you like, from the production side, the Euro HPC LUMI machine in this case, and there will be a similar installation at Leonardo. And from here, this is like a cloud system. Information is provided to a core platform provided by ESA, from where you can access this information. So one example would be our Polytope service, which is essentially allowing you to data cube access in time or in space to very specifically targeted regions. This will be available as a core service to users to the platform, and they can then use this service and embed this in their kind of like, they can basically register an advanced application on this core platform, which uses this data service as one component, but then builds on that. For example, you can think of the simplest way. An advanced service could be collect, time series of all the most important cities in Europe. And you could use the Polytope service to do that. You could collect it there and make it available in a more convenient form for researchers then to access the thing. So kind of like we provide the raw diamond, if you like, and then the system allows you to kind of beautify it and make it more easily accessible and embed it more easily into, say, subsequent applications such as urban models and so on. So that's sort of in a nutshell, if you like, one pathway how you can envision it.
Okay, thank you, Niels. Any question from the audience? So no questions, Lido. So if not, I think that we can thank again Niels and we can go to the next speaker. So thank you very much again.
Okay, thank you.
So we have now a second remote presentation. This presentation is being given by Bartek sorry for the pronunciation, Tokarz. Also, we have Beata Bartsova connected that she will also support with the questions and the rest. Both are from DG Connect, Unity 1, Research Strategy and Program Coordination, Strategy Digital Investment, and the presentation will be covering the European Digital Infrastructure Consortium. So the floor is yours. You have about 15 minutes plus 5 more questions. Thank you very much.
Thank you very much. My name is Bartek Tokarz. I'm head of sector for strategic digital investments in DigiConnect. My team is in charge, among other things, of the deployment of new instrument to support multi-country projects, so large-scale digital projects under Digital Decade Policy Program. So this new instrument, it is EDIC, European Digital Infrastructure Consortium. So I would like to discuss today with you the basic features of this EDICs. I'm also here with my colleague, Beata Bartoszova, who is here to answer your questions. I also need to apologize. You will not be able to see us because there is some problem with the camera, and Beata is changing my slides, and we are working from 2 different locations. So sorry for any kind of inconvenience caused by this. So once again, thank you very much for the invitation. Thank you very much for being here and your interest in this new instrument. And the European Digital Infrastructure Consortium is instrument created under Digital Decade Policy Program. The Digital Decade is a process leading to the achievement of 2030 digital goals of the Union. So really radical, deep digital transformation of economies and societies, actually, with core objectives in the areas of skills, government, business, and infrastructures, with very strong link to the values, and with a governance mechanism which allows member states and the Commission to track progress, discuss, and develop recommendations on the actions that needs to be undertaken. So Digital Decade as a sort of second pillar of the Digital Decade, apart from the setting of the targets, the monitoring the progress, it is the implementation of multi-country projects. Multi-country projects are large-scale digital projects which typically require cooperation between many member states and the Commission, may require cooperation with other categories of partners, such as private entities, international organizations, etc. And these multi-country projects may be implemented by various instruments, such as IPCIs, such as joint undertakings, such as ad hoc consortia created by member states, but also by a new instrument that we created, so European Digital Infrastructure Consortium. Next slide, please. So what is the EDIC? The European Digital Infrastructure Consortium was a concept developed based on a very positive experience that we have with European Research Infrastructure Consortium. So ERIC is a research infrastructure consortium, has been created many years ago to support research infrastructures. It's operated, the whole ecosystem is operated by DG RTD. I think that you may have heard about it, you may know this instrument. What we have done is we took this legal framework and we adapted it to the needs of large-scale digital projects focusing more on deployment rather than on research. And we rendered it a little bit more flexible because we see that these are the projects that will grow, will develop, so we need to provide some more flexibility to the implementation. So an EDIC is a legal entity, a legal person, which is set up by decision of the Commission upon request of member states, and there needs to be a minimum of 3 member states, created by the Commission, so it has a legal personality and full legal capacity recognized in all member states. So it is basically a new legal person where decisive role is in the hands of member states who are members of the EDIC, and with the role of the Commission relatively limited, as I will explain in subsequent slides. So it's very much a member states driven instrument. It is funded first and foremost from commitments of its members, but it may receive grants from various sources of funding, including EU programs such as DEP, CEF, Horizon Europe, RRF, also from other grant programs at the national level, etc. Next slide, please. So what are the basic features of the EDIC? Firstly, it's a strong position of member states in EDIC governance. So member states who provide financial and non-financial contributions are members with voting rights. Then other member states may join as observers without providing contribution. Member states, while applying to the Commission to set up an EDIC, in their application, they submit draft statutes of the EDIC. And in the statutes, they decide basic features of this instrument, including whether third countries, international organizations, public or private entities can become members. However, always member states have the guarantee of at least minimum of a minimum of 50% of the voting of the total voting rights. And the Commission is not a member of the EDIC. It doesn't have voting rights. It has only limited procedural rights in the operation of the EDIC. Most important are 2 rights of the Commission. Firstly, the Commission may veto decision of the EDIC when it comes to actions which are financed from directly managed EU instrument. So if, for example, we give a grant from Digital Europe program, then we can veto a specific decision of the EDIC which concerns its financing. Of course, this is not something which we'd like to use often. It's like a last resort measure. And the second, the Commission also has effectively a veto right when it comes to amendment of the statutes of the EDIC. So we have also the control there. But other than this, all the decisions are taken by the Assembly of Members of the EDIC and the EDIC director. An EDIC must be open for participation of all member states. So throughout the life of the EDIC, member states can join on fair and reasonable terms to be decided. It's also a difference from the EDIC. There is this stronger guarantee of the openness of the EDIC. Next slide. We have a couple of policy and legal issues applicable to the EDIC. Of course, this is not a comprehensive list, and of course, please treat my presentation as a rather general introduction, only very general introduction. The topic is quite complex. There are quite a lot of issues, so maybe if you have specific questions, we will address them later. But the main points which characterize the EDIC, the legal status, we have already said that this is the new legal person created by Commission decision and governed by member states, controlled by member states. The contribution of members can come in the form of financial and non-financial contributions. What we are seeing with while negotiating, while discussing the first EDICs with member states, it is that this issue of financial contributions is particularly important. These financial contributions are necessary, firstly, to make sure that EDICs can function. So, for example, you have to pay the salaries of the director, the secretariat, different sort of legal fees, expert fees, but it's also necessary as a co-financing of EU grants. The rights of members and observers are in general characterized in the Digital Decade Policy Program. However, the member states, when adopting the statutes of the NEDIC, can modulate these rights to a great degree. EDICs may be involved in economic activities, so we expect that there would be EDICs which would focus exclusively on economic activities, and then there would be those who will be doing some economic activities. They may be entitled to tax exemptions. This depends on internal structure of an EDIC. We can also get back to this. But EDICs which have public entities as members, basically, they can be they can benefit as international organizations, so tax exemptions. In terms of governance, the Digital Decade Policy Program is very flexible. It recognizes only two compulsory bodies of the EDIC: it's the Assembly of Members, the main decision-making body, and the director. Then EDIC may, in the statutes, member states may decide to create different sorts of advisory bodies. As I say, the role of the Commission is limited. And then important point also is the voting rights at the Assembly of Members. Here there is also a very large degree of flexibility. There could be different methods of calculation of the voting rights. It could be one member, one vote. It could be proportional to member states' contribution. And then finally, there needs to be a set of policies, so the rules on various aspects of the financing of the EDICs, such as ownership of intellectual property, data protection, procurement, employment, and what I even put to a separate slide because it's quite important, state aid. This all needs to be decided upfront in the statutes. Next slide. So I know that this is a very short, very preliminary introduction. So let me say about the support that DigiConnect provides to the EDIC ecosystem as such, and to individual EDICs. This is a function really of the Commission, which is described as multi-country project accelerator in the Digital Decade Policy Program. So we are responsible for several aspects of the process dealing to the creation of the EDIC. So we are advising on the, we can provide advice on the draft statutes of the EDIC. We cooperate with member states who are interested in creating those EDICs. We have also launched a pre-notification process So this is the process under which we, in a non-binding way, ask member states about their interest in creating EDIC in a specific area. But the most important is that we see MCP Accelerator first and foremost as an informal support mechanism for member states, where basically member states interested in EDICs can come to us at any time to ask questions, to meet and to discuss any specific issues, which may be either related to their decision-making process when they at the stage when they think whether they should have an EDIC for a given area, or later when it comes to really preparing the application, drafting the statutes, etc. Next slide. So I think that we will stop with this slide. This is where we are now. As a result of this pre-notification, member states submitted to us 8 EDIC proposals, including one EDIC where there has been already a formal application. This is a proposed EDIC for blockchain. And then we have 7 EDICs pre-notified. So pre-notification means that while it's informal, non-binding, voluntary procedure, these are EDICs where there is a strong policy support. There's proposed EDICs when there is a strong policy support from member states, when they already have a reasonably detailed information on what, how the EDIC would be structured, what it would involve, in which area specifically it will intervene, what would be the implementation plan, etc. So in many of these proposals, we hope will result in the EDIC being created. As you can see, once again, these are very diverse policy areas. I will not go through all of them, but please do have a look. We have EDICs basically going from addressing health, like genomes. We have very much industry focused EDICs like mobility and logistics data, and we have potentially very large scale EDICs which are based on advanced artificial intelligence technologies. This is the Alliance for Language Technologies. So this is where we stand. Thank you very much, and maybe we can take some questions.
So thank you very much, Bartek, for the presentation. I see one hand raised at the very end. There are questions here. Please bring him a mic or her a mic.
Hi, my name is Anna from SERI. I have 2, maybe almost 3 questions. So the first one is, how is the role of associated and non-associated countries? Can they participate as members or observers, particularly when it comes to non-associated countries? How could they get funding when the funding, you can also access, for example, funding from DEP? And then the second question is, what is exactly the advantage to an ERIC? And how would, for example, research infrastructure and health go together with an EDIC in genomes? Like what is the added advantage of an EDIC in comparison to an ERIC, and how do they work together? Thank you.
I guess, did you get the questions?
Yes, hello.
Yeah, we can hear you.
Great. Good afternoon, everyone. This is Beata Bartoshova, colleague of Bartek from DG Connect. And first of all, the question on associated countries and their membership or possible membership in the European Digital Infrastructure Consortia. We regulate the EDICs, the European Digital Infrastructure Consortia, via the Decision on Digital Decade Policy Program. So there is no separate regulation or legal text for the EDIC. Everything is regulated via the Digital Decade Policy Program decision. And this decision outlines that the multi-country projects that are implemented by the EDIC or other tools can combine a number of member states or other entities. And for the EDICs, the membership is linked to either EU member states or associated countries that are already associated to a funding instrument that is covering digital priorities of the Commission. So there is Article 11.3 in the Digital Decade Policy Program regulation, which is expanding a bit on this, but the main point is that the third countries can be members of the EDIC in case this third country is already associated to a union funding instrument that is covering digital priorities. And in terms of your second question on the comparison between the ERIC, European Research Infrastructure Consortia, and the EDIC, European Digital Infrastructure Consortia, the main difference is already in the title, I would say, because the ERIC is embedded in research, so it's covering projects in the area of research, whereas the European Digital Infrastructure Consortia is more focused on deployment. So it's an option for projects that are further away, higher TRL, in the area of deployment beyond research.
Thank you very much for the answer. Any other questions in the audience? Yes?
Thank you. I would like our colleague from DG Connect to elaborate a little bit more where the EDICs are situated in the landscape of EOSC, research infrastructures, and national nodes, and all this landscape, wonderful landscape, because all the research infrastructures are producing data. That's why we are here. For example, if you have this European Language Alliance, there is a research infrastructure, many, but one as an example is Clarin. Clarin is basically a database of language data and tools, and is Clarin in the proposal for this EDIC for because I don't understand how it goes together, because then the ERICs will be members of an EDIC, or the EDICs will be members of an ERIC. Will the EDICs be members of the national nodes? Will the EDICs be connected to the EOSC? What is the idea? I don't really understand the connections. Thank you.
Mm-hmm. Thank you for the question. So to position possibly the EDICs in the data landscape is a very complex question. So I would say the idea of an EDIC and the project that they want to implement and how this is going to work is to a large extent depending on the member states' agreement. So member states have a lot of scope to define in the statutes of the EDIC the objectives of the EDIC, the mission of the EDIC. They have to prove how the EDIC is contributing to the digital decade targets. And they also have to flag the relationships of the EDIC with the main actors in the area. For the specific EDIC that you pointed out, the ALT, the Alliance for Language Technologies EDIC, we are now in the process of replying to pre-notification. So the member states have put together the initial idea on how this EDIC should operate, what the mission should be, what the objective should be, and how it should be implemented. And we have just, as a commission, sent this week, earlier this week, the initial feedback to these thoughts. And we are still not at the stage of real formal application being submitted. So what I am saying is let's say, a snapshot in the current moment, and the idea is still evolving. And for the moment, what the members of this potential EDIC are talking about is 3 areas. First, it would be a repository of existing datasets related to language technologies. Then it would be possible development with the use of AI and other technologies of language and multimodal data models. And the third one would be facilitating the access to high performance computing.
Okay, so thank you very much. I think that we have to go to the next. Is that this, or maybe we have one just. Oh yeah, sorry, one comment. There was one follow-up comment to this.
Yeah, I just wanted to maybe clarify where the EOSC stands in this perspective. So the EDIC was one of the other potential governance models that we have been discussing initially. And yesterday I said that some of these models were like discarded from the initial list at the tripartite event in May. And that's why yesterday we haven't presented the EDIC as an option. But you should consider this as this ideally was another potential option for a governance, okay?
Thank you so much, Sarah, for the clarifications. So I think that we can...
I'm sorry, if I may, just one more very short comment, because the previous colleague was asking whether the EDIC is going to be the member of the EDIC or the other way around. So this would be, again, up to the decision of the founding members, whether they want to have the EDIC as a participating entity or not, or the other way around. So it is largely to be decided by the members and defined in the statutes. But finding their space and the relationship with the main actors within the landscape, within the relevant landscape, is a prerequisite for the submission of the application.
Okay.
May I also add to this? We wouldn't like to have very complex structures, adding to what Beata said. I mean, EDICs being members of EDICs or vice versa, I think it would be rather exceptional, very exceptional situation. We would rather expect that EDICs and EDICs would focus on different parts of on different aspects even. When they coexist for a given area at all. So that EDICs would be indeed focused more on deployment, where we have something large scale, ready to be deployed, whereas EDIC would be more research oriented. I should also say that our legal base, EDIC, is more flexible also in the sense that we are able to combine research and deployment activities, whereas EDIC is strictly research. So when you have a more complex initiatives which involve both the research and the deployment, an EDIC would seem more natural solution.
Okay, thank you so much for the clarifications and the presentation. So let's have an applause.
Thank you very much. Thank you. Grateful to be here, and we look forward to talking to you again. Thank you.
Thank you.
Thank you.
Okay, so let's move to the last presentation, which is a physical one. It will be given by myself, so I didn't introduce myself before. So now is the time. So you may know me by other roles, like being member of the Board of Directors Association, but here I'm acting as the responsible of the central node of the European Cancer Imaging Infrastructure Project. So we will have the slides coming, I guess. So yeah, what I would like is very quickly give you a view of what is this project about, which is also something that is quite related in the area of the data spaces. So let me go quickly. So I will just skip the content and go directly to the point. So this project is focused, maybe if I take This one is, okay, it will be better for me. So it's focusing as one of the flagship initiatives in the Europe's Beating Cancer Plan, right? So which focus on the areas of prevention, early detection, diagnosis, and quality of life. So it is framed in a complex ecosystem in which we have the data spaces, which are focusing on having the data from health available, managed by the citizens, available inter countries, and also making a trustworthy system in order to use there for secondary use and research, which we have the pilot there. The testing experimental facility, which are focusing on using the data for developing new products in AI and robotics, like the TEF in AI and robotics, and flagship projects like the GDI, Genomics, and UCAIM that focus on European Cancer Image Federation. So let's go with this in detail. Next slide. Right, so what is the purpose? Cancer imaging datasets exist. There are many of them available around different research projects, different institutions, different initiatives. But they are scattered and not easily accessible. So what we want is to have using the digital technologies to have an open infrastructure for cancer imaging in which we can link those resources and make them available in considering the different types of uses, the different access conditions, and the different consideration that they have. So we will provide this means for accessing and thinking on the interoperability at the level of the European Health Data Space and, of course, at the level of EOSC. So this project is is led by a hospital in Valencia and has 76 partners. I will show you very quickly. And a budget that is close to 36 million co-funded, 50% commission, 50% the partners and the countries. We have the major research infrastructures and like Eurobio, ERIC, Elixir, BMRI, ERIC, and Diatris ERIC involved there. So the list of partners is vague, it's very large, so I wonder that many of you can find your institution there, which makes the project a challenge in order to coordinate all the activities. Also, we have several stakeholders that are acting as providers in different lines. Right, I can tell you that there's one partner missing in the slide that it will be difficult to find. So vision and mission. So we want to enhance cancer diagnosis and treatment using AI tools, right? So but we need this hybrid federated infrastructure. Why hybrid? Because we have to deal with different types of access models, different types of restrictions, different types of capabilities. There are hospitals and research centers and projects. They have the data. They finish with the research. They have the data viable. They would like to make them preserve for the long term, and they don't have the means to do it, right? And then we need a central place in order to put the data and some data stewardship to gather this. But also they have centers that they also have the data on the premises, and they will not allow a very flexible access to it. So we have to cope in this hybrid federated scenario. We will provide this platform for the development and benchmarking of AI tools, and we're trying to address the fragmentation. The aim is to have 60 million of anonymized cancer images, but I'm really sure that it will be beyond that. So what's this complex slide try to summarize the following idea. So we have on the right side the existing data that comes, that is already available in the repositories, on projects, on research infrastructures. We want to index this data to have a comprehensive catalog of all this data and facilitate the access to this data through the different means that we, and respecting, of course, data sovereignty. But we want this data to grow, and then we consider also the left side, the observational studies, to grow and prepare a platform in which new studies collecting new data can be developed, and this new data, reduce it, anonymize it, will form part of the global atlas in the future. So with this, let me very briefly go to the actors. So we have three types of actors there. We have the providers. Agreeing the name of the provider is not that easy. There is a very strong legal work package in the project defining exactly the condition of access, and we have different types of actors that will provide data as a federated node or directly uploading the data in the platform. We have the providers of tools. Tools should be, and we will have a marketplace of solutions for the processing of this data, because there will be cases in which we will only provide federated access, federated learning, distributed processing without visualizing the data. And of course, we have the data user, which will be the researcher. The main actor will be the researcher, and I will come up just right now. So the process is that open as possible, restricted as necessary. So we cannot provide full open access to data to anyone. We can provide full open access to the metadata of the collections, but the access to the data should be granted under a specific condition. That you have a project with a specific research mean, that you have the approval of the ethics committees, that you have the consent of your institution to do this project. Otherwise, it will infringe the data agreements that we are signing with the providers. So this complex workflow try to solve these things. So you see the public data available. You then identify potential relevant usage, data set that you would like to access. You request access to this data through the means that we have through a negotiator. You provide all the information, and again, you granted access to this data that becomes part of your library, your catalog of access data. Right architecture, very briefly. I don't want to go into very details of that. Just would like to leave the slides there. We have defined 10 components that are building this federation. Some of them you will recognize as the typical components that you will have in any federated infrastructure for data. So this is even a little more complicated with a little more of detail, but try to see that we have a central approach. We have a central dashboard that have the minimum information, which is the metadata of the data set that we have, the catalog. Along with the catalog, we have the interfaces for getting more detail, federated query, and a user area in which you will be able to run distributed processing over the federation, right? Depending on the capabilities of the system. Since many of the providers will not be able to have their own processing capabilities, there will be a central node. This central node, or several central nodes in our case, will be acting as a catch-all for this data that need to be preserved. So going to the details. So we started in January, 79 partners, 4-year project starting in January. So it was really a challenge to have organized it ourselves, and we put a very strict deadline on the end of September, which means 2 weeks, in which we'll have a first version of the platform running. So this platform will be this subset, this central catalog with federated query capabilities, negotiation system in order to get the data through a dashboard that will be connected to the life science AI system. So as you see, it's quite aligned with all the other activities that are being done in the area. So we already have a catalog with 35 datasets. It may not seem a lot, but we have more than 200,000 series of images, which means several millions already of images available, annotated and made available with the proper anonymization. We'll have federated query engine to deep dive and try to identify which are the best or the suitable data sets, and an access negotiation service to manage all the process. There will be a distributed prototype for the processing, a prototype for the distributed processing, which will not be fully linked. So some snapshots of the dashboard of our catalog of data sets, our federated query. I will go into detail very, very briefly, but this separation in between two lines, the metadata of the data sets, the metadata of the data allow us to cope with different levels of standardization. And then this will be the point that I will discuss in a minute. And this a negotiation that will be the main entry point provided by BMRI to request access to the data. Also important thing that we foresee 3 levels of access. Providers that can give you the right to download data, data that is made available with the proper consent for that. Providers that will give you access to the data on control environments. that they have. Virtual environment, you can run some processing, you can see the data, you cannot download, there's no network outbound connectivity. And even you have the third case, the restricted one, cases in which you can run some processing from the catalog of the marketplace, but you cannot even display the data. I can tell you that the regulations, even regional regulations, are in some cases impeding this secondary use of the data for research if this not this specific condition. So we have to deal with this scenario. So just to very briefly, so the data comes from different types of sources, and as I mentioned, the requirements of the users are only the research project. We'll go quickly on that. All the slides will be available later on. So for the data, so we have agreed that all the data sets will follow a strict common ontology, the specification with agreed terminology for all the data sets. So the data set metadata will be fully interoperable and fully fair. The data, it's more difficult to guarantee a full compatibility between all the data that we have, because projects that end up and they don't have, they didn't know about the new ontology that is being developed in the project, will not have the resources to migrate the data. There will be something that should be done along the time between inside the infrastructure. We expect that also projects that have their own ontology will link to the system, but linking to the system will not force them to change the data structure. So we'll consider data mediation in the middle. Along with this, we will define a level of tiers in which you have different levels of compliance with respect to the system. So data should be anonymized. In some cases, we will allow pseudonymized data. If you ask several data processing officers, they will say images are never anonymous because images are unique. It doesn't matter if that's a slice of your abdomen, you cannot recognize anyone, but it's a unique data. And then this is pseudonymized, so you know. And then several levels of harmonization, annotation, labeling, cleaning, coherence, a lot of data stewardship actions that should be done in cooperation with the provider. So that was the idea. So we have this standard metadata for the catalog, and we have this mediation in which you can link your own catalog without having to restructure your data. That will be the only way to ensure the acceptance of the system. So ending up, let's talk very briefly on sustainability. So let me say that the sustainability of the platform is quite linked to the sustainability of the data of the projects. If the projects end up and need a sustainability plan for the data that they have produced, then the UKAIMS comes in place, right? So we will offer this possibility, and we will gain for that the capability of exploiting this data with several considerations. So it's very important that a proper exploitation model is defined in order to use this properly. So we are focusing on an edict. We already have an expression of interest of an edict with 7 countries there. We are not in the level of the pre-notification, because pre-notification, if you have seen in the previous presentation, puts the clock ticking. You have 3 months, 5 months, and we have to be sure that we have everything in place before we give the first step. And that's my end slide. So UKAIMS at consolidating the cancer imaging research community. Data is extremely sensitive and complex, requiring a widely accepted legal framework. Federated model will be key to fulfill the legal constraints, and the construction the federation is much complex than it seems, even technically, because it requires dealing with many different use cases. Of course, fair principle interoperability with other actions in health and other interdisciplinary areas will be key to, especially for cancer research. And that's all from my side. That's the timeline. Thank you very much. I don't have any, if there's questions around. I see one there.
Hello, Ignacio. I noticed that all of your data that you presented are experimental. They are all contained in images that have been taken in the lab or in the clinic. There's a lot of work that has been done on the tumor microenvironment of cancerous cells with simulation models, theoretical models done on the computer, and then there's comparison between the real images that you get and the simulation. And as you know very well, the images have a great variability. Some images are very poor, some are better, some are, and so on. So my question now is, in your system, do you plan or do you have already made some databases of theoretical models possibly to compare with experiments?
That's a very, very important point, absolutely. I mean, we have focused initially on real-world data and DICOM standard as the main shows, but we want to expand for this. I mean, we had a project that is one of the contributors there, which is pretty much in which we also had the possibility of getting, I mean, aside with the system, the results of simulated models. These are very important, as you say, for the validation. This is something that we have to consider, and we are approaching different communities, but we want first to get the mandate that we have at this moment and try to increasingly put this data. Moreover, there are research infrastructure that already have this data well organized there, and we would like to link them and try to leverage all the experience that we have. So we don't want to solve the problem by ourselves totally. Any other question? There's one from Georgia.
Many thanks, Mauro Campanella, GAR. It is a comment, I just request a comment on the fact that you might want to extend what you're doing outside Europe or not, and if you see any challenge there, because NIH in the United States, for example, what is your opinion on that?
Yes, indeed, there are very good data sets already being used in the United States from the NIH. It's very well used. So the point is, I mean, it's on the table, right? So how to deal with the international connection. We start with this European-based initiative. We cannot forget this thing. We already have one activity of internationalization that we'll try to see if we can, I mean, link this through the federation. That will be something that will be on the road for sure. I think that we put in the hat of the moderator again. We can close the meeting, the session, sorry. So thank you very much for the attendance. Thank you to the participants. Let's have lunch. Until what time? Yeah, you see the next session when the next session is starting at 2:30. Sorry, 2:30. So we have 1 hour, 20 minutes more or less.